In this last lecture on consumer theory, we're going to put everything together. We're going to combine budget constraints and indifference curves to figure out how consumers make choices to maximize their utility given the constraints of their income and prices. We're going to see that the decisions that consumers make relate to the bang for your buck rule that we discussed a few lectures back. Lastly, we're going to talk about income and substitution effects just a bit, which break down how changes in prices of goods will change consumers' consumption of the different goods in their consumption bundles. So we can think about consumers' behavior as a utility maximization problem. Consumers' goal is to maximize their utility. So we all want to make ourselves as happy as possible, but unfortunately we have constraints. We have limited income, and the goods that we want to consume are not free. So what we want to do then is get on the highest indifference curve possible, that's maximizing our utility, subject to being on or inside the budget constraint. So we will always end up on the budget constraint because we can't be as happy as possible if we have unspent resources. So consumers will always spend all of their money on the goods that they are purchasing, and that will ensure that they are maximizing their utility. So the consumer optimum will look something like this. So this is a graph showing, again, pizzas and Pepsis. And you can see that there are indifference curves on this graph. Those are the orange lines and the red line. And there is a budget constraint, and that is the purple line, and the budget set is the lighter shading of purple inside the budget constraint. Our consumer's optimal bundle that they could consume here is 4 cans of Pepsi and 3 slices of pizza. So how can we see this? Well, take a look at the consumer's different indifference curves. The indifference curve 3 is the highest possible indifference curve that this consumer can get onto. Consumer would rather be on indifference curve 4, but there's no part of indifference curve 4 that lies on the budget constraint or in the budget set. So that is just not a feasible allocation. That's not a feasible consumption bundle for our consumer. Also take a look at the point on indifference curve 2, which happens to lie on the budget constraint. So our consumer could spend all of their money and purchase 2 cans of Pepsi and 4 slices of pizza, and our consumer would be spending all of their money, but that consumption bundle lies on indifference curve 2, and the consumer would rather be on indifference curve 3. So instead of consuming 2 Pepsis and 4 slices of pizza, our consumer is going to purchase 4 cans of Pepsi and 3 slices of pizza. So note what is true about the relationship between the indifference curve and the budget constraint where our consumer ends up consuming. Note that those two things are tangent, and that's going to be important when we come up with a mathematical relationship for what consumers are going to do. So at the optimal point, again, the slope of the budget constraint and the slope of the indifference curve will be the same. That is what happens when two lines are tangent, their slopes are the same. Well, we know what the slope of the budget constraint is, and we know what the slope of the indifference curves are, so we can come up with a mathematical relationship from what must be true with these two things when the consumer is maximizing his or her utility. So the slope of the indifference curves is given by the marginal rate of substitution. The slope of the budget line is given by -1 times the ratio of the prices. Okay, so we can substitute some stuff in here. Remember that the marginal rate of substitution is -1 times the marginal utility of good x over the marginal utility of good y. Well, let's put that together. We can rewrite that condition in the yellow box then as the ratio of the marginal utilities of good x and good y must be equal to the ratio of the prices of good x and good y. All right, finally, let's just do a little bit more algebra, a little switcheroo here, and we can get that the ratio of marginal utility of good x divided by the price of good x has to be equal to the marginal utility of good y over the price of good y. This is the bang for your buck rule that we talked about a few lectures ago. And again, this describes what must be true when the consumer is maximizing their utility. So when this condition holds, that means that the budget constraint and the indifference curves are just tangent to each other, and the consumer is reaching the highest possible indifference curve that consumer can reach given that consumer's budget constraint. Okay, so now we can talk just a little bit about how things change if one of the prices change. So remember that if a price changes, that will rotate the budget constraint. So here we're going to go through an example where the price of Pepsi increases from $1 to $2 a can. Okay, so this is going to be the end result. So our consumer was consuming 4 cans of Pepsi and 3 slices of pizza. The price of cans of Pepsi increases, and our consumer is going to choose to consume 2 cans of Pepsi and still consume 3 slices of pizza. So this is our end result. But there are a few things that are going on behind the scenes here with respect to how many slices of pizza the consumer chooses to consume. So you may remember a long time back we talked about complements and substitutes. So complements are goods that when the price of another good increases, the demand for a complement will decrease. Substitute, on the other hand, is defined by when the price of another good increases, the demand for the substitute also increases. Well, here we've got a special case where the price of Pepsi increased and the demand for pizza didn't change. So this is a special case where the goods are neither complements nor substitutes. But in general, whether goods are complements or substitutes or just are not related is determined by income and substitution effects. So the substitution effect is if good X becomes more expensive, we're going to buy less of good X and relatively more of good Y. So that is due to the change in the relative prices of the two goods, the change in the slope of the budget constraint. So we're going to substitute away from the relatively more expensive good and substitute into the relatively cheaper good. Now there's also something called the income effect. So a change in the price of a good causes a change in our purchasing power. So if the price of good X goes higher, that means that our income has less purchasing power because every unit of good X we purchase eats up more of our income. So that means we're going to choose to buy less of both goods. So what we want to do is find a way to separate the substitution and income effects. So how can we do that? Well, if we have two goods, X and Y, and the price of X increases, the substitution effect says we're going to purchase less of good X and more of good Y. The income effect says we're going to purchase less of good X and less of good Y. So you see that the effect on good X is not ambiguous. The substitution effect says we're going to purchase less. The income effect says we're going to purchase less. But the effect of good Y is ambiguous. The substitution effect says we're going to purchase more of good Y. But the income effect says we're going to purchase less of good Y. So we have these competing effects in this case. So we're going to try and figure out which one dominates. Okay, so this graph lays everything out for the substitution and the income effects. So let's take this step by step. So we're starting at our old optimum point, which is the budget constraint 1, which is shaded in light purple. On indifference curve 3, we're consuming 4 cans of Pepsi and 3 slices of pizza. So at the end, when all is said and done, we're going to be on budget constraint 2, consuming 2 cans of Pepsi and 3 slices of pizza. So we're going to talk about how we get from 4.3 to 2.3. Okay, so to find the substitution and income effects, do the following steps. 1. Draw a budget constraint parallel to the original budget constraint, but tangent to the new indifference curve. So you can see that that will be the green budget constraint. So this allows us to optimally be on what will end up being our new indifference curve, but at the original prices. So the tangency point between this new budget constraint and IC2 is a point labeled A. So the movement from the original consumption point, 4 Pepsis, 3 pizzas, to point A, that shows the income effect. How did our consumption change due to only changing the real income, not changing the relative prices? So this is, again, a jump along 2 budget constraints, showing a change in the budget. The movement from this point A to the end consumption bundle of 2 Pepsis and 3 pizzas shows the substitution effect. So what we're doing is basically holding our purchasing power constant, holding our utility constant, and rotating our budget constraint from the green budget constraint to budget constraint 2. So this says when prices change, how do we reallocate consumption to keep our happiness constant? So, in conclusion, the point of consumer maximum utility is found at a tangency between an indifference curve and the budget constraint. And at that point, the slopes of these two things are equal. And that is what determines, and that is how we derive the bang for our buck rule. And what we can do then is use indifference curves to separate the substitution effect and the income effect when we talk about changes in the prices of goods.